Methane can also get trapped in pockets beneath the ocean floor. 1981 in the South China Sea. A drill ship hit a shallow gas pocket, causing a blowout. As gas bubbled to the surface, it made the ship unstable, leading it to capsize and eventually sink. Any large-scale disturbance on the seabed, such as an earthquake or landslide, could dislodge a substantial slab of methane hydrate, which would turn to gas as it floated to the surface. So a methane hydrate release could potentially have caused the USS Cyclops to capsize, especially given that her design left her prone to rolling. But the only way to determine what really happened to the ship is to find her wreckage.
Having studied as much as I could about approximately how far the ship may have made it from her departure point, I think she probably was about a day out of port, and she probably wound up around the northwest area of Puerto Rico.
Marvin's hopeful that the wreck site may one day be found.
To find the resting place of Cyclops and my great uncle and all the others who served with him would mean a lot.
But if Marvin's calculations are correct, the ship won't be easy to recover. Draining the area reveals a trench up to 5 miles deep, the Puerto Rico Trench. This is where the triangle reaches its deepest point. In fact, it's the deepest point in the entire Atlantic. As scientists explore the massive underwater feature, they're finding it could conceal the deadliest of all the Bermuda Triangle secrets. The source of a potentially devastating tsunami. The deepest part of the Bermuda Triangle, the Puerto Rico Trench, could conceal its deadliest secret. So scientists are racing to explore this most inaccessible of underwater regions. Here in the National Geographic Society's remote imaging laboratories, they've developed a radical new technology for filming the deep ocean. It's called drop cam.
Perfect. Good to go.
After years of development, lead engineer Eric Birkenpass was ready to test his camera in the ocean off Chile. It's unpowered. A heavy weight pulls the camera down.
There was still a lot of butterflies in our stomach when we actually threw it over the side into the real ocean.
When the team deployed it in the Puerto Rico Trench, it took an hour and a half to travel the 5 miles to the bottom. It was programmed to spend several hours more on the ocean bed, then resurface and transmit its position.
There's a huge sense of relief when you first hear that VHF beacon on your radio transmitter and you see that satellite fix.
These are among the first images from the bottom of the Puerto Rico Trench. 5 miles straight down. The Deep Sea Imaging Project has given us a window into one of the great unexplored regions of planet Earth. But their images are a series of snapshots, capturing an area of just a few feet square at a time. In order to drain the whole Puerto Rico Trench, we need much more data. US Geological Survey scientist Yuri Ten Brink is attempting to map the entire feature, and he believes there's a very pressing need to do so.
We started researching this trench because it is very similar geometrically to the Sumatra Trench, where the 2004 Sumatra earthquake and big tsunami happened. And that was a big worry here because a magnitude 9 earthquake on the Puerto Rico Trench can unleash a tsunami that will hit the US East Coast and even Europe.
Yuri's team deployed remotely operated underwater vehicles called ROVs to scan the trench and assess the tsunami threat level. The ROVs fire sonar pulses to obtain as accurate a readout as possible. Their 3D mapping reveals the sheer sides of vast underwater canyons.
In some of the valleys and rifts, there are sometimes walls that can be like 1,000-meter high or something like that.
Geologists have long known the trench formed as the edge of the North American tectonic plate moved underneath the Caribbean plate and simultaneously slid against it. But what the new data now suggests is that this could be prime underwater landslide terrain.
They can move rocks in areas that are many hundreds of kilometers squared, size of big cities and more actually. The thickness of the rocks can be 200 meters or more, so you are talking about altogether 10, 20 kilometer cubes sometimes.
So an underwater landslide on this scale might potentially threaten the eastern US with a tsunami, just as Yuri feared.
You think of Boston, of Charleston, of Baltimore, and you think of all the nuclear power stations that are along the coast. And so you have to prepare for it.
The terrifying impact of a tsunami on an insufficiently protected nuclear power station is now well understood, following the 2011 Fukushima disaster. For an equivalent tsunami to reach the US, there would need to be a magnitude 9 earthquake in the trench. To understand the odds of a quake on this scale, Yuri's team sampled rock cut from the bottom of the trench and analyzed it back in the lab. What they've learned will come as an immense relief for anyone living on the East Coast, though if you live closer to the trench, it could still prove disastrous.
From our current understanding, we are not sure that it's capable of such large earthquakes. That not to say that it's not capable of big earthquakes, magnitude 8 to 8.5, that could also happen. They may not hit the US East Coast, but they will still cause tremendous damage in the Caribbean.
It's also possible that an earthquake centered in the trench could trigger a methane hydrate release, a further hint that these may be responsible for some of the area's notorious disappearances. Yuri's completed data allows us to drain 500 miles of the Puerto Rico Trench. Given its vast scale and immense depth, it's perhaps no surprise many of the triangle's missing ships and planes remain lost. There are spectacular sheer cliffs, several miles high. It's truly an awe-inspiring landscape at the very bottom of the Atlantic Ocean, 5 miles down. Draining the Bermuda Triangle has shown us for the first time a stunning range of highly varied terrain, including some of the strangest features known to exist in our oceans. The myths and legends of the triangle are persistent and deep-rooted. Yet we've discovered that the dangers posed by this area don't appear to come from any supernatural phenomenon, but from the very real and very deadly forces of Mother Nature herself.